Hello guys, welcome to today's episode on isoperimetric problems. Like I said in my previous video, if you watched, I said I'll be solving a few questions or a few exercises on isoperimetric problems. So currently we're working on this question which goes thus: find the extremal of the functional integral from 0 to pi y prime squared minus y squared dx under these conditions. In the previous video, I explained that you'll be given different boundary value problem, like different conditions, and then you'll be given a constraint, right? So I'll explain this very well. Then if you've not watched the previous video, please do that for you to understand more of what I'm doing here. And I gave a tip in the previous video. I'm sure you guys have been enjoying the videos. If you have been, please do subscribe to my channel to get more interesting videos. Also, do help me like the videos when you enjoy them. Thank you. So now we have our functional this. Then I told you that this is your f, right? Your function f. And I said that you can name your constraint to be g of x comma y prime. Then this lambda is called the Lagrange multiplier. So this I don't think I talked about this lambda in the previous video, but then I said it's a constant, but then it is called the Lagrange multiplier. So you multiply it to your constraint. Now I said this is our constraint to be this, and your g should be your constraint, and then your f should be your functional. Then you introduce a new function called h of x comma y prime to be equal to addition of both multiplied by lambda and your constraint. So we have this. Then that means we'll have to extremize this. Then if we are to do that, I'll have to use the Euler's Lagrange equation. And Euler's Lagrange equation states that you have d dx of di f di y prime minus di f di y equals 0. But here there's a mistake in this. It should be di h, not di f, because we're going to be doing this. Sorry, so this should be di h, not di f. So we have di h di y prime minus di h di y equals 0. Just like we've been doing in previous videos, right? I said you look for your di h di y prime and di h di y. Same here. We'll look for our di h di y, and I've explained how to differentiate any function that is being given to you. So let me take a clean sheet. So if you want to differentiate di h di y prime now, look at this is your function, right? So di h di y prime implies you're going to differentiate partially with respect to y prime. Any other thing that is not y prime taken as a constant. So here I have y prime here, so it should be, so my di h di y prime will be 2y prime. This is not y prime, so it will be 0. So I have 2y prime. Then my di h di y will be anything that is not y will be taken as a constant. So that means this one will be a constant. So I have 0 minus 2y plus lambda. So I've explained how to do all this in my previous video, so you can watch to understand more. But then that's how to do it. Then you impute everything into your Euler's Lagrange equation. That's why I have it to be d dx of 2y prime minus this equals 0. So you're going to use minus to open the bracket so that you have d dx of 2y prime plus 2y minus y equals 0. Because minus times minus will turn to plus, and you have minus here equals 0. Then don't forget, I told you that we're always looking for our y. So we'll try to reduce y prime, and get our y, excuse me. So here I have 2y prime plus 2y minus lambda equals 0. I can just take lambda to the other side, so that lambda will stay alone, and y prime and y will stay alone. So I'll divide both sides by 2. I have y prime plus y equals lambda over 2. Now to solve this, the other ones we'll be doing, we've probably been separating variables or looking for how to integrate. Now to do this, we're always looking for our general equation, right? So we can use the knowledge from homogeneous and non-homogeneous differential equation to solve this one. So which I'm going to make videos of this evening. So just try to subscribe to my channel if you've not, and then turn on your notification bell to get notified immediately I upload videos related to this. So if you want to solve this, you have to first solve the homogeneous part of the question. Now, and the homogeneous part of the question is when this is equal to 0. So that means you have y prime plus y equals 0, which is something as r squared plus r equals 0, or you say d squared plus 1, not r, because this is not raised to power any pi, plus 1 equals 0. So you get your d. When you get your d, we have our d to be equals to plus or minus I, because you have d squared equals minus 1, and then if you do square root of minus 1, then it will lead to complex, so we have it to be plus or minus I. So it means if you have d to be equal to plus or minus I, the same thing as d equals 0 plus or minus I. And remember that anytime you have this, the same thing as a plus or minus b. I'll be making videos on this very soon so you understand better. So that means your a is this. So your general equation will be y equals to e raised to power ax into brackets c1 cos bx plus c2 sin bx, where your c1 and c2 are called constants. So that implies here our a is 0. So e raised to power 0x is what? 1. That's why I think write 1 here. Then your b is what? Sorry, a plus or minus bi. So your b is the coefficient of I, and the coefficient of I here is what? 1. That's why we have it to be c1 cos x plus c2 sin x. Now our y particular, so for you to solve this now, I said you first solve the homogeneous part, right? But then to solve this, your y equals your y complementary plus y particular, and this is your y complementary here. Now when I get my y complementary, I need to look for my y particular, right? And to get my y particular, it depends on my g of x here. This is what we call our g of x. So if I have, let's say here that I had lambda over 2, if I have it to be x squared, then my y particular will now be a plus bx plus cx squared. But here, and if I have my g of x, which is here, to be equal to x, for example, then my y particular will just be a plus what? Bx. But now I have my g of x to be equal to a constant lambda over 2, so I'll still equate it to a constant. So I'll now say my y particular is equal to a constant a, anything you want to call it. So me, I'm calling it a. You can call it a naught, you can call it b, you can call it anything as far as a constant, an arbitrary constant. So now to solve this, since you already have a y particular, but then you need to look for the value of a. Now to look for the value of a, this is how you're going to do it. You multiply your homogeneous part, your d squared plus 1, multiply by your y particular, and equate it to your g of x. So there are different ways. This one is a bit straightforward. You can decide to different. Don't worry, I'll make videos on this later on though, but this is the way I'm going to use it to solve this one, to make everything fast and easy. So we have this. So this squared means you differentiate this twice. So you open the bracket, you now have this squared multiplied by a plus 1 times a is a equals lambda over 2. Now this squared, a means differentiate a twice. A is a constant, right? So if you differentiate a constant, you still have what? 0. Even if you differentiate it 100 times, you still have what? 0. So you now have 0 plus a equals lambda over 2. That means your y particular, which is equal to a, will then be lambda over 2. So then your general y will now be, so your y will now be c1 cos x plus c2 sin x plus lambda over 2, which is your what? A. Right? Now you can now insert your conditions. You know, in the question we were given that y of 0 equals 0, y of pi equals 1, right? So that means you insert, you know, I told you in the first video that anytime you are solving, you are looking for your constant and your what? Your Lagrange, your lambda. So now we need to look for c1, c2, and what's lambda. So if you want to look for c1, c2, and lambda, how are you going to do it? It's so straightforward. You just put in your boundary, your conditions to get your c1, c2, and then or your c1 and your lambda, either ways, and then equate your y into your constraint to get your last constant. So you don't have to cram, just go through the same process that I've been going through to solve any question related to this. Now, we said y equals c1 cos x plus c2 sin x plus lambda over 2, right? Now, the first condition is when your y equals 0, y of 0 equals 0. And I've explained to you that in mathematics, when you see this, it implies that your y equals whatever you have here, which is 0, and your x equals whatever is inside the bracket. So we now have, so since y is 0 and x is 0, we'll have 0 equals to c1 cos 0 plus c2 sin 0 plus lambda over 2. And your cos 0 is 1 and sin 0 is what? 0. So I have this one to be c1. Take this to the other side. I have minus lambda over 2. Attending to the second condition, you have y of pi equals 1. It implies that what? Your x equals pi and your y equals what? 1. If that is the case, I'll just put it inside this general equation. I'll have 1 equals c1 cos x plus instead of x you have pi cos pi plus c2 sin pi plus lambda over 2, where your pi equals 180. So 1 pi equals 180. So now, since you know your pi equals 180, if you check, cos 180 is minus 1. So therefore, I'll have 1 equals to minus c1. And cos sin 180 is 0. So this one will go away. I'll have lambda over 2. Then I can make my c1 to be the subject of the equation. Then I'll have c1 to be equal to lambda over 2 minus 1. So now I have two c1s. c1 equals c1, right? Anytime I write c1, c1 is c1, c1 is c1. So if c1 is c1, then I can equate c1 to c1. Now if I equate c1 to c1, it implies that I'll have my lambda over 2 equals what? Lambda over 2 minus 1. Now I'm looking for lambda, right? Just normal mathematics here. Take lambda over to the other side, anyhow you want it. You have lambda equals what? 1. That implies that your c1 equals, irrespective of where you're going to put your 1, you still get the same thing. So your c1 is minus 1 over 2 here. Same here too. 1 over 2 minus 1 is what? Minus 1 over 2. So your c1 is minus 1 over 2. So we've gotten lambda and c1. What else are we looking for? Our what? c2. That means, since that is the case, I'll just go to my general equation, which is this, right? And then go to my constraint. What is my constraint in the question? I said 0 to pi y dx equals what? 1. Now I'll just come here. Since I have this, what is my y? My y is what I've gotten before, and my y is c1 this and this and this. So excuse me, so it implies that this one will be c1 cos x plus c2. You can do it either ways. Either you put in your c1 and your lambda first before putting inside the integral to make your work fast. So here, what's your c1? Minus 1 over 2. What's your c2? We're looking for c2, right? And what's your lambda? Your lambda is 1. So I have 1 over 2, the x equals 1. So we integrate with respect to what? To x. Now, if I am integrating with respect to x, it implies that if I integrate cos x, I'll have what? Sin x. If I integrate sin x, I'll have minus cos x. And if I integrate 1 over 2, I'll have what? X. Then you put your 0 to pi. Now, that means I will have, anytime anywhere I see x, I put pi. Minus anywhere I see x, I put what? 0. So that means I have minus 1 over 2 sin pi. I said pi equals what? Pi equals 180. So then minus c2 cos pi plus 1 over 2 pi. Then minus this minus open brackets. When you have it to be 0, have everything to be 0 equals 1. So don't forget that your sin 180 equals what? 0. Cos 180 equals what? Minus 1. So minus times minus return to what? Plus c2. Then pi over 2. This one, cos 0 is 1. So I have minus c2. Minus times minus your return to 1 plus c2 equals 1. Then you have 2c2 equals this. Right? 1. Take this to the other side. Sorry. So you have 2c2 equals 1 minus pi over 2 over 2. Then your c2 automatically, using normal mathematics, you have, this will be 2 minus pi over 4. Now you've gotten your c2, you've gotten your pi, and you've gotten your what? C1. Now you can have your final solution, which is what we've been looking for. So then we'll have our y. So then we have our y equals what? 1 minus 1 over 2 cos x plus 2 minus pi sine x over 4 plus 1 over 2, because this is your c1, your c2, and this is your what, pi, which is the required what, extremal. Thank you so much for watching. If you really did enjoy this video, please do like and subscribe to my channel, because I'll be uploading more and more interesting, beautiful videos for you to enjoy. Thank you so much and have a nice day.